Hello everyone, hope you guys are doing amazing. So, beautiful problem from the Spain Math Olympiad 2000. The problem is a functional problem, as many students requested for the functional problems. It's pretty easy. We have a function is defined in the natural number to natural number domain and range, or sometimes we call it positive integer, right? The function is f of n is n plus 1. Then what is going to be the general form for f of n if it exists? So to solve this problem, uh, first of all, I can solve this way, that f of, can you see that? Yeah. So f of n plus 1 will be, to get some idea, so instead of n you put n plus 1. It's going to be n plus 1 plus 1 is n plus 2. Okay, now you can see that you can see in this way that if you call f of n as, let's say, y, right, then f of y is n plus 1. Okay, and f of y is f of n plus 1 if you take a function from both sides. Okay, so f of y based on this relation is gonna be y plus 1, and f of n plus 1, you just leave it as f of n plus 1. Or instead of y based on this relation, you can put f of n. Longest story short, f of n plus 1 is f of n plus 1. That means we have a arithmetic sequence, okay, with the common difference of 1. Okay, so in arithmetic sequence, probably you know that we have like something like this. For example, a n plus 1 is a1 plus d common difference times n minus 1. Okay, so this one is like f of n plus 1. This one is f of 1. D is 1. And we have n minus 1. Okay, so we know that f of n plus 1 will be f of 1 plus n minus 1. But how about f of 1? What is going to be the value? Is there in this range natural or positive integer? Is there any f of 1 exist? Let's see. So f of how can I solve this one? I can do this one in this way. So if I take a function again from both sides, what happens? That will be f of n plus 1, okay, let me bring it up, is gonna be f of the whole term right hand side, which is, let's start by n plus f of 1 minus 1. This term, this is like a constant. Okay, there is no n involved, right? So n plus some constant. Okay. Of course, because both range and domain are integer, positive integer, we expect that both n and f of 1 minus 1, f of 1 minus 1 is gonna be integer, positive integer. So f of 1 minus 1 is integer. That means this guy will be, of course, integer, right? Great. So we go forward and we will see that there is no integer exist to assign as f of 1. Okay? So so let's back to here. F of n plus 1 can be written as, look at this one, is n plus 2. F of n plus 1 is n plus 2. So I can write it down as n plus 2, okay? Or I can do also another thing. I can say that n plus this constant is like a u, okay? Then f of u will be u minus f of 1 plus 1 plus 2. Okay, by combining both those two relations. Okay, so if you put this one u, then here this guy is n plus 2. Then instead of n, you can put u minus f of 1 plus 1, right? So u minus f of 1 plus 1, and then bring this 2 to the other side, which appears here. Okay, great. So if little bit simplify that, this one will be u plus 3 minus f of 1. Okay, great. Or you can change it, because n is familiar, instead of u I can back to the symbol n, so f of n is n plus 3 minus f of 1. Okay, good. Now look at this one. F of n is n plus 3 minus f of 1. On the other hand, f of n, where is that? Okay, on the other hand, we know that f of n, okay, is f of n is f of 1, okay, f of n is f of 1 plus n minus 2. Okay, so we know that f of n plus 1, which is f of n plus 1, then it's gonna be f of 1 plus, so this guy will be equal to n plus 3 minus f of 1. Okay, then if you bring f of 1 to the other side, just look at this one. So 2f of 1 will be n, and n cancel each other. This 2 goes to the other side, is gonna be 5. That means f of 1 will be, can you see that? Okay, it's gonna be 5 divided by 2. Okay, so we can see that this one is not natural number. Okay, natural number, it's not natural number, so we can reject that. So that means there is no function which satisfies this relation in this range and domain. Okay, so no function exists. All right, thanks so much. If you like it, make sure you share with your friend and subscribe and like the channel. Thank you. Bye.